Calculate the barycenter of Jupiter and the Sun given the following information. Mass of the Sun 1.989 times 10 to the power of 30 kilogram. Mass of Jupiter 1.898 times 10 to the power of 27 kilogram. Mean distance of Jupiter from the center of the Sun 7.78 times 10 to the 11 meter. And the mean radius of the Sun 6.96 times 10 to the 8 meter. Is the barycenter inside or outside the Sun? Alright, so we're given the masses of the two, that's the Sun and Jupiter, and the mean distance between the two, and the radius of the Sun, and we are asked to find the barycenter. Barycenter basically means the center of mass, so X, CM, center of mass between the two. And we know that the center of mass of any two objects is given, or any number of objects for that matter, is given by the sum of the mass and its corresponding distance from the axis of rotation divided by the mass, the sum of all masses. Now, what are those distance from the axis of rotation? It depends upon the choice of the axis of rotation. So, if you have our Sun, for example, something like here, center is right here, it's the Sun, and this is Jupiter, the center is right here. We know their masses, and we know the mean distance between these two objects. We know the distance from the center of Jupiter to the Sun is given as R sub Sj. Now, the choice of rotation, axis of rotation, is arbitrary. You can choose any. For our convenience, if we choose our axis of rotation to be right here, this is axis of rotation. Then the distance from the center of the Sun to the axis of rotation, which is along it, is going to be x sub s, and that's equal to 0. With this axis of rotation, with this reference, the distance of Jupiter, the center of Jupiter, is equal to R sub Sj. Let's represent it by x sub j for convenience. Now, based on this, what is the center of mass going to be? It's going to be mass of the Sun multiplied by its corresponding distance from the axis of rotation, which is x sub s, 0 in this case, plus mass of Jupiter distance of Jupiter from the axis of rotation. Divide that by the sum of all masses, that is, we mean mass of the Sun plus mass of Jupiter. And let's plug in the numbers. So the center of mass x sub m cm is going to be mass of the Sun, which is given to be 1.989 times 10 to the power of 27 kilogram, multiplied by 0, that's the distance of the center of the Sun from the axis of rotation, which is along that center, plus mass of Jupiter 1.898 times 10 to the power of 27 kilogram, and its corresponding distance is the mean distance between the center of the Sun and Jupiter. That's equal to 7.78 times 10 to the power of 11 meters. Divide the whole thing by the sum of the masses. Mass of the Sun, which is 1.9 9 times 10 to the power of 27 kilograms, 40 kilograms, that's the sun, plus 1.898 times 10 to the power of 27 kilogram, the mass of Jupiter. That yields 7.42 times 10 to the power of 8 meters. So the center of mass of the sun and the moon is 7.42 times 10 to the 8 meters, meaning both the sun and Jupiter orbit this center. Now the second part of the question says, is the barycenter inside or outside the sun? So basically what we are asking here is the barycenter, which is XCM, greater or less than the radius of the sun? That's the question asked. And we know that RS is 6.96 times 10 to the 8 meters. Now, is this less or equal? X sub cm is greater. Therefore, because that value here is, and therefore this is less. What does that mean? Now, this is R sub S. So, we know that 7.42 times 10 to the 8 meter is greater than 6.96. That's 7.42 times 10 to the 8 meters is greater than 6.96 times 10 to the 8 meters. And what does that mean? Because the common center or the barycenter is greater than the radius, the x sub m is outside, so it's going to be somewhere around here, outside the radius. It's greater than the radius. The radius is here, and this center is right here. Therefore, it's greater than that, so it's going to be outside. So the sun orbits this center, and so also Jupiter orbits this center.